All right, 30-1s. So second lesson of chapter 10 is the next two operations, right? So we've already covered adding, subtracting, and functions, right? We did that kind of over 2 days, sort of. Okay. So now we're going to cover multiplying and dividing. So please make sure notation. Remember from last week, right? If I do f plus g all in brackets and then an x on the outside, that just means take your f function and add it to your g function. Those two things mean the same thing. Okay, you'll see them interchangeably. Sometimes they'll write it like this side, right, to have you do it, or sometimes they'll write it like the right-hand side. Either way, they mean the same thing. Same thing with subtraction. So this is what we did last week, right? That notation just means take your f function and subtract your g function. So the notation today is with multiplying, right? And it's at the top of your sheet. I'm just kind of going through it again. So with multiplying, it could look like that, right? The f and g in the same bracket side by side, right? With the x outside, which just means now take your f function and times it by your g function. Those two things mean the same thing, right? So be prepared. Either way, I can write it either way, and they mean multiplication. And vice versa, if I have f over g with the x outside, that just means take your f function and divide it by your g function. So those are the four notations for the different operations of functions. And now, are they always going to be f and g functions? No, it can be whatever functions. It could be a p function. It could be an m function. That really, the number outside, or the letter outside doesn't really matter, right? Because the functions will be given to you in the question. All right. So just like last time, guys, I'm going to do a few with you guys, and then I'm going to let you go. Because believe it or not, you've done a lot of these operations without using that notation before. All right. So this first one just says given f of x equals x plus 2 all squared minus 5, and your g function is a linear function, 3x minus 4, you're going to determine the new h function, right? So the new h function you're going to find by taking your f function and multiplying it by your g function. That's what that means, right? State the domain and range of h of x. So you're definitely going to be using some algebra skills, right, to simplify these functions. So your h function is going to be found by taking your f function and timesing it by your g function. So do the substitutions. So my f function is x plus 2 all squared minus 5. And we're going to times that by my g function. So realistically, could I stop there? Could you guys? You could, because it doesn't say a simplified, right, h of x function, but you know that I'm not going to stay there. Because on a diploma or a test, if it was multiple choice or numerical response, would they ever leave it like that? Never, ever, never. Okay, so let's just go ahead and expand all that and simplify it. So inside here, I'm going to get x squared plus 4x plus 4 minus 5. And then I have that 3x minus 4. And remember, guys, is everybody okay with me saying x squared plus 4x plus 4? Because x plus 2, right, squared means there's two of them. So I expanded it all in my head. You guys should be able to do that by now. And I keep going. So then I have so go ahead and expand it. Don't look up till you're done. Somebody else got the same numbers as I did? Now that I put the square on there and changed the 2 to a 3. All right. Are we good? So state the domain and range. So what kind of function do I have? Cubic. So do I need to touch my calculator to get domain and range? Can you guys all visualize a cubic? So what's the domain? What's the domain, guys? Right, x is an element of all reals. Do I have any restrictions? No, no restrictions for x, right? I can put any numbers in, right? Any real numbers in. Now, if you remember what a cubic looks like, remember it's a graph that has endings going in opposite directions, right? And there might be a little bit of a weird scenario on the inside, but it's either like this, right, or like that. So the range is, guess what? Also the same. It's all real numbers because it goes forever up, forever down. If this ended up being a degree 2, would we have had to touch our calculators to get the range? Yes. The domain would have, because if it's a polynomial function, guys, you know that the domain, there's no restrictions. So then it's all real numbers. But for polynomial functions, the range is the piece, right, that is affected by the output. So odd degrees, ends are in opposite directions, so it's always going to be all real numbers. But even degree polynomial functions, there is going to be a max or a min, which you would have to use your calculator for, guys, because you cannot find max or mins of higher than a degree 2, okay, algebraically. Once we do calculus, you can, okay, but right now you have to use technology to find a max or a min on something higher than a degree 2. All right, so I'll just throw it down here. So there's my domain and my range. So just a quick little conversation, guys. Remember when we did adding, subtracting, how we could sketch the graph if I gave you the 2 originals? Remember if I'm asking you to add 2 functions together, what did you guys do if I gave you the 2 original functions on the grid? You would just take all the outputs, yes, right, and add them together to get the new point, right, because the x values stay the same. So, and same thing with subtracting. So does it make sense that we're going to do the same thing with multiplying, dividing? Yes. So if I give you 2 functions, right, on a grid paper, and I ask you to sketch the multiplication function, all you do is take the 2 outputs, multiply them together. That's where the new output on your new function is. And same thing with division, okay? So go ahead and do the your turn. I'll just do it behind you guys. And I might pipe up once in a while if I have something to say. So with this one, guys, do I want you to do anything with that? No. Could you, if I asked you to, though? Could you move that x squared underneath? Absolutely. But again, guys, if you move that x squared underneath, aren't you actually unsimplifying it? Yeah, but maybe on a diploma, they wouldn't have wrote it like that and they would have put it underneath, which again, doesn't make sense to me that they would do that, but could they? Because it's all about equivalencies, guys. So to me, this is the most simplified, so I wouldn't touch it. That's perfect, okay? But would you guys freak out if they wrote it? Don't write this down. Would that be the same? I kind of wrote it really scratchy, sorry. Do you guys agree that an x squared on the outside becomes an x to the power of 4 on the inside? Yes. So then could I multiply that to the linear that's underneath there already? Right, so x to the power of 4 exponent 4, right, times 2x is 2x to the exponent 5 minus 3x to the, and this is still with a whoops, oopsie, I just erased everything. That's still with a square root over it. But again, would I want you to do that? No. Would I hope that you guys are okay if somebody did it? Yes. Because you guys know how to move stuff back and forth from a radical, right? And if you don't, you need to come talk to me, right? We can move variables underneath back and forth, right? We can move numbers from underneath to outside and vice versa. Okay. But to me, you'd want it in the most simplest form, right? So when you're dealing with radicals, the most simplest form is whatever can come out from underneath should come out. So this would be what we would go for, because this is going to help us with domain and range. All right, so nothing to do there. So it says, given the graph of f of x and g of x, sketch the graph of h of x on the same set of the coordinate axes. So again, guys, since we have the function in front of us, could you guys just type that into the calculator and get ordered pairs off of it? Yes. Is that what I want you guys to do? No. If you're doing that, then you're literally not using your brain at all. You're just using the calculator, which again is fine to check. But I was really nice here. And did I actually put the originals on there for you guys already? Yeah. If those originals weren't on there, by all means, type the h function into your calculator and sketch it, right, using your calculator. But since I gave you the two original functions for you, I would hope that you would push yourself to use these two to get your multiplication factor. So is there restrictions here, guys? Where does the graph start? Think of domain. Where does the graph start? 1.5. Does it make sense that it starts at 1.5? Yeah, because that's the restrictions on x. That's my domain of my new function, right? And you can see it here, even though it's in between. You might be thinking, well, it's in between 1 and 2. But if we look at our new function, you guys do know for sure that it does start at 1.5, because that is my restrictions, right? So I might as well do my domain right now, because it's going to help me with my sketching. So my just restrictions on x of my h function, right, is where 2x minus 3 is greater than or equal to 0. So my domain does start at 1.5. And it goes to the right. And also, what about my range? If you guys look at your h of x function, the output is always going to be above 0, right? Because this piece right here, right, the square root piece has to be positive. And then the piece outside is always being squared. So is the piece outside also going to always be positive? Yes. So we do know that the range, without even sketching the graph yet, I would expect you to know, just by looking at the function, the new function is going to be greater than or equal to 0, just through reasoning, right? What you guys know about the function. So I'll shut up now. You guys go ahead and sketch. And remember, guys, I keep saying I'll shut up. I'll shut up. Morgan, put your phone away. Do your sketch. It's like I'm literally right here, and you're like, nah, I don't care if I'm on my phone hanging out. Sorry guys, I should have given you more bigger graph paper. Then when you're done sketching, put it on the calculator to confirm that you're good. Oh no. Did you all get that kind of weird? Again, I should have given you bigger graph paper so you could plot a couple more points. And did you guys notice, did I kind of do a little bit of issues? Yeah. Did it make sense I went issues? Yeah. Just because it wasn't perfect, right? So I knew approximately where my points were going, right? And remember, you just take your outputs, right? And multiply the numbers together. Yeah. Right? It doesn't though. Because remember, guys, when you go on your calculator, sometimes, because does this look like it's going vertical a little bit? So you have to be careful on your guys' calculators because depending on what operating system you have, is your calculators will not graph non-functions. So as soon as the calculator starts kind of going vertical on top of each other, that it looks like it's right on top, sometimes your calculator will just stop graphing it. But you guys know from the function, does it touch the x-axis at 1.5 from the domain of the function? Yes. Will your calculator necessarily show that? No. So that's why this is always what you're using, not what your calculator's showing you, right? When you're graphing, because like I said, sometimes it'll like look like it doesn't go all the way down. Okay, so please, 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 does the function tell you it goes all the way down? Yes. So you have to do the math, guys. And again, if you guys go into your table of values, is this a problem too if you don't understand what's going on? Because your calculator is only right now, you can start it at different ways, but it looks like it starts at 2.4. But does it start at 2.4? No, because the domain, right, your restrictions on x starts at 1.5. So the only way that's going to show up in your table of values is if you tell it to, right, by changing your table set, which to me, we don't need the calculator anyway, right, to be able to do this question. But you always have to make sure, that's why I force you guys or tell you guys, whether you do it or not is up to you, to push yourself to not depend on this, because this will lead you astray, right, if you don't know what's going on, right? You cannot use your calculator to do the course. You can use it to help you manipulate a few things, but it will hurt you sometimes if you're not careful. did we get everything for this one? We did domain and range. We did our H function. We sketched our new graph. We're good. Right. So the first two were two multiplying ones. Okay. And then 2 and 3 are just division ones. So have we actually did some division of functions already in 20-1 and 30-1? Yeah, right? We've done rational functions, okay? So rational functions are really two functions put together, okay? So this first question we'll actually have done already in the past. So determine the equation of the function h of x, right? And we're going to take our g function divided by our f function. So go ahead and do that. And remember, guys, h of x equals 2x plus 6 over x squared plus x minus 6 is the new h function. But if you want to do domain and range, can you leave it in that form? No, because you need the restrictions on x. So it makes sense not to stop there. So just like we did literally in chapter 9, go ahead and finish this question, just so we can answer the whole thing. So what numbers did you put in for the domain? X cannot equal what? Perfect. And for y cannot equal? Okay, so I heard negative 2 over 5. Thank you. Is there 2? So a lot of you learned after your quiz, you have to be really, really careful with your range, right? Because in this scenario, does it have a point of discontinuity? Yeah, I didn't ask for it, but the point of discontinuity, right, is at negative 3, comma, remember you put it back into your simplified function. So if you put negative 3 back into that, you get negative 2 over 5. Remember, guys, that is an open circle. If you were graphing it, it is an open circle on your graph. So the input cannot be part of your domain, but the output cannot be part of your range. Some of you forgot to put the output point as part of your range scenario. So be very, very careful. And then also your vertical and horizontal asymptotes, right, have to also be part of the not equal to. So we know that this function is bigger on bottom, right, the exponent. So if it's bigger on bottom, we know that the horizontal asymptote is at 0. So that's where this 0 came from, right, is there's a horizontal asymptote at 0 and a break in the graph at negative 2 over 5 is outputs, right? And then my vertical asymptote is at 2 and my point of discontinuity is at negative 3. So both numbers have to be there. All right. So go ahead, do the next one. you're done already, you can do the next one. This one's really hard to get your point of discontinuity because it's so close to the x-axis, but so guys, if you did not have the original functions, do you guys know how to see where your vertical or POD is going to be? I'm assuming you guys all did it without the equation. Did you not? That's what I asked you to do. So where are those asymptotes or point of discontinuities going to occur if you're just looking at a graph? So if I asked you for this one, if I said, again, don't look at the questions. I don't care about the questions right now. If I said f of x over g of x, where are the possible, because you don't know if it's going to be a POD or a vertical asymptote. You don't know which one. But where would they occur in this scenario? At what numbers? Right, where g of x equals 0. So where is that on this graph? Right, at 3 and negative 3. Okay, if I switch this, if I did it this way, is it now different? Absolutely. So in this case, the second case, there's going to be a vertical asymptote, right? Or, well, these are absolute value graphs, so there isn't going to be a POD, right? So these ones would have vertical asymptotes at which two numbers? Right, okay, just making sure that you guys got that, okay? Because you're not always going to have the functions. So, and also there's a typo, because isn't on yours, does it say the graphs of two quadratic functions? Yeah, so change that. They're definitely not quadratic, they're absolutes. Right, so the graphs of two absolute value functions. And then you guys can see, do example 4 and example 5, and then we'll make sure that you got them right. So this would be your typical diploma question. Not given the functions, answer the questions. Oh, the other thing, guys, I haven't showed you this notation. I don't like, they very rarely do they do it using this notation, but with multiplication, guys, it'll either be written like this for multiplication, like this. Okay, sometimes they'll put a little dot there in between. Okay, So if there's a dot in between, not an open dot, that's important because there's a new notation where there's going to be an open dot between F and G, which is not multiplication. But if it's a closed dot between F and G, that just means it's multiply F times G. And the textbook questions I'll write on the board as well. You're welcome. I just want to make these ones a little bit nicer. Just trying to make my sketch a little bit nicer because I moved my asymptote over by accident. I think I erased it and put it back in.